viewers. This is Afe Ademola Johnson, your chemistry tutor. We'll be looking at the likely questions that will come out in NECO practical chemistry this year 2024. And I have some questions here. So let's look at it. Now, with me here on the board, the question is A is a solution of 0.138 mole per dm³ tetraoxosulfuric acid, H2SO4. B is a solution of sodium triisobicarbonate 4, Na2CO3. Then there's an instruction here that we should put A into the burette and titrate it against 20.0 cm³ or 25.0 cm³ portion of B using methyl orange as indicator. Then repeat the process of titration for 2 or 3 more times. Then after that, say we should tabulate your burette readings and find average volume of A used. Now, let's go to titration. The question says I should put A into the burette. This is the burette. This is my A. So, what I'm doing here now, I'm pouring here. Okay? So, I have it here. Now, when I'm filling, I want you to take note of one thing. Now, look at the burette. The A inside now is at 0. You can see 0 here. This is 0, 1, 2, 3. So at 0, you can see the meniscus. The liquid bends inward inside. So the tip of that meniscus touching this line shows that my initial reading is 0.00. And from the table, it's showing that my rough reading. Now, take note of one thing. When you are tabulating, first thing to do is to write size of the pipette. Because the question said you should titrate using either 20.00 or 25. But the size of the pipette that is usually common, that we are using in this place, is the one that is 25 cm³. You can see it here, 25 ml. That is the size of the pipette. You must always write it. Very important. Size of pipette equals to 25.00 cm³ before you begin your titration. Because it will enable the examiner to know the kind of marking scheme to use to mark your script. Whether you're going to use the one where the burette is 20 or the one where the burette is 25. So you have to indicate it there so that you don't get the examiner confused. So since I filled the burette to 0.00, my initial reading here will be 0.00. So now I'm through with that. I can come and titrate now. What I will do with my burette, he said titrate it again 25.0 cm³. So this is my pipette. Sorry, not burette, pipette. This is my B. I'm going to suck this B. I'm going to suck it until it touches a ring here. Okay, so you can see it here now that the liquid is at this level. It's at this level now. So that is what I have. What that means is that the amount of B inside here now is 25 cm³. Let me rinse my conical flask with the content of B so that I can be assured of what a good work. Then I pour into a zinc. So then I want to release the bee inside the conical flask. This is a conical flask, and I'm already releasing it. You can see it now. I'm releasing it inside this conical flask. I'm releasing it inside the conical flask. It's taking some time. So I'm through. So he said, using methyl orange as indicator. Using methyl orange as indicator. This is my methyl orange, and the color of methyl orange. Let's watch the color of methyl orange inside B. You can put 2 or 3 drops of methyl orange. You can see that methyl orange has turned yellow inside the solution of B. That is one of the confirmation that you are working with a substance that is alkali, or a substance that can hydrolyze to form alkali. So I want to titrate. Now, as I am dropping this acid inside here, I'll be shaking it until the color changes from yellow to pink. When it changes from yellow to pink, then I will stop the titration. And you can see that the thing is already trying to change. It's already trying to change. So very soon, you see the pink color. Yeah, it has changed now. You can see, look at the color, the pink color. This is a pink color now. Then, having done that, the next thing to do is to come and read the burette reading. This is 41. Come to this place, 40. This big line is 40 cm cube. 40.1, 40.2, 40.3, and 40.4. So that is 40.4. So I will put that one here in my final reading. Is 40.40. Make sure that your reading is in 2 decimal places. So if I take away 0 from 40.0, what do I have? I have 40.40. Then I want to fill that burette again, maybe until it gets to 0.00 again to start, because he said I should repeat the process of titration for 2 or 3 more times. So I am putting my A inside here. So I remove my funnel. Okay. This is at meniscus already. So I want to throw away the initial thing. You can read from there. So now I want to pipette again. So I want to pipette B. Yes. So I'm taking it to a conical flask. I'm releasing it already. That's my B. I'm releasing my B. Now, I have that. Then my methyl orange, you can put 2 drops or 3 drops as the case may be. You can see that the solution has turned yellow. So I want to start titrating now. So I have to be releasing my acid inside here and be shaking. The reason I have to shake is to hasten the rate of chemical reaction by making the reactant particles to be at close contact. It's about to change now. Yes, it has changed. So I want to check. So what I have here is quite totally different from what I used to have before. This one is 29.1, 29.2, 29.3, 29.4. So that is 29.5, this longest line. 29.5. 29.50. So if I take away 0.00 from 29.5, I will get 29.50. Okay? I want to start again the fresh one, so I will have to discard this one. So discard this one. So the second reading now. So I will rinse here with the B that I was using it for before. Then I will fill up the burettes with A again. I'll remove the burettes. Okay, so I want to pipette again. I have to swap. Okay, so I'm releasing this into the conical flask now. So then I'll put my methyl orange, 2 drops or 3 drops. So then the solution is yellow already. Then I will come here and titrate. So now it has changed again. This time it is 29.1, 0.2, 0.3, 0.4 and 0.5. Exactly as what we got before. 29.50. And this is 0. I've filled it to 0. So this is 20, if we take this 0 from here, we have 29.50. So I will still fill this one now to 0, 0. Then let me fill it again, and then let me discard what I have here. And then rinse it with the base, with the B, with sodium triiodocarbonate 4. Then fill the burette again. So we are there. Okay. Okay. I release it to my conical flask. Then after that, I put my methyl orange, 2 or 3 drops, and I have it there. So then I titrate. Yes, it has changed now. So this time is what? It is 29.1, 29.2, 3, 0.3, 29.3, 29.3, 29.30, then 29.30. So I am done with the titration. You can see from the table. So what we are left with now is calculation. So I want to look for my calculator. Okay, the question is asking us, this is the table, this is what they expect you to produce. You will see that one thing to ensure is that between one titer and another titer, the difference between them must be between 0 and plus and minus 0.2. Because between this one there's 0 difference, no difference. But between 29.5 and 29.3, we have 0.2 difference. So it means we are doing the right thing. So the average data value, we will not talk about the rough. In fact, you can even cancel the rough like this, cancel it like this, and start the first titer, that's 29, that can come in, 29.50 plus another 29.50 plus 29.30. Everything over 3 because I've done it 3 times after the rough. The rough making it 4 times. So my answer will now be, in my calculator, I want to add them together. I have 29.50 plus 29 0.50, then plus 29.30. What is it giving me? It's giving me 88.30. 88.30 divided by 3. What is it going to